Hey guys, I hope this works well. This is my third time trying this. Um, so I would like to, throughout the course, maybe upload videos of me teaching. I know I'm not in the classroom, I'm not at the whiteboard, it's not the same experience, but I can try to do something. I would like to teach, show you guys some math, so that when things get more difficult down the line, the problems can be longer. I would like to be able to come on here and explain a few things, work through problems with you. Um, I would like to say that if you are in these review sections and you are having trouble, I would suggest that you guys seek out some help, seek out tutoring, um, do what you can because you have to have a strong foundation in calculus to do well. If not, it's going to be tough for you guys. So nip it in the butt now if you can. Get that help now, early on. Please do not wait until it's too late because calculus moves quickly. Once we get in there, we're going to move quickly. Every day, you're going to feel like you're doing something new. Um, it's going to take a lot of work, but we can do it. Okay, we can do it. Um, so I hope this works well. Um, I want to go over a few things with you guys. And like I said, you have to bear with me. Okay, so this is chapter R. You have these PowerPoints in my math lab where you can go in and review them. They have all the work, they have the answers. Now, what I do when I teach is I take these same PowerPoints. Sometimes I add a little in there, not much, but I will delete some things because sometimes it's just too much to cover in a class. But what I do is I take all the work off and I go through each example and I teach it and I explain it the way the way I understand it. Um, so that's what I would like to do with you guys is go through some of these examples sometimes and teach it and explain it the way I want to explain it. But I don't have time to do the entire PowerPoint with you guys. Um, so just really quickly, I would like, and I don't know if you guys can see me, I may get out of focus because I'm actually writing on the screen, so I'm not sure how it will look. Um, but the screen, you know, the notes is what's important. So a few things here I want you to make note of. There I go already messing up. Um, we have these parentheses and we have these brackets. So those are two big differences there. I want you to make note of also that you have what we call interval notation, set notation, and then you just have the graphs. Um, if you haven't been in a classroom in a while, you probably forgot, when do I use the parentheses? When do I use the brackets? If you remember, the parentheses means that the number is not included. So if you look right here at this set notation, what this is saying is that X is strictly between A and B. X is greater than A and less than B, right? But X cannot be equal to A or equal to B. Down here, X can be greater than or equal to A, and X must be less than or equal to B. So what I'm trying to get at is that in this first part here, the A and B is not included in the subset. It's not included in the answer. So that's why we close that interval in interval notation with parentheses because we cannot include A and B in the solution. Whereas in the second example here, we close it in with those brackets because now X is greater than or equal to A and less than or equal to B. So X could be equal to A and X could be equal to B. The A and B is actually included in the answer there in the interval notation. So that's the difference between the brackets and the parentheses. Brackets means the number is not included. Parentheses, I'm saying that wrong. Parentheses means the number is not included. Brackets means the number is included. And the only other thing I would like to add is that down here at my infinities, if you pay close attention to those infinity signs there, and I'm going to move to my next slide as well. So here I have negative infinity, and negative infinity. All of my infinity signs are closed with parentheses. Infinity grows and it goes forever. It's not bounded. So you can't contain it, right? So you can't include infinity. Infinity is kind of like a concept, right? So in short, whenever you have an infinity sign, you put parentheses and not a bracket. Okay, so I'm gonna move on. I wasn't going to go over too much there. So I'm going to skip through a lot of this. I think you can get through it. What I want to jump to is that domain and range. That's where students kind of have questions. Okay, what's going on? Okay, so if you remember, domain is just your x values. Okay, example 3, let's just clarify. It says example 3, find the domain. And it says f of x is equal to the absolute value of x. So when I see that, what I'm asking myself, and it's on the screen there, is what can we substitute into f of x? What values work in that equation? Then you should think to yourself, is there any number that I cannot substitute into that equation? Because sometimes you try to plug numbers in, they don't work. You get something that's undefined, right? So think about the absolute value of x. Is there anything there that's going to give me any trouble? Can I substitute negative numbers in there? If I were to take and find f of negative 2, well, that's going to be the absolute value of negative 2, which just gives me what? Positive 2, correct? So it looks like I may be able to plug negative numbers in there. What about 0? Can I substitute 0 in there? If I find f of 0, that's going to be the absolute value of 0, which just gives me 0. Well, then what about positive numbers? What if I find f of 3? Well, f of 3 is the absolute value of 3, which just gives me 3. So in short, what I'm trying to get at, it looks like I can substitute any type of number I want to into this function, and it'll work fine. So my domain can be any number that I want it to be. So my domain for this would be from negative infinity to positive infinity. Okay. Now, that one's kind of simple. And so we're going to go through and look at some different ones and kind of discuss what they have in common, what's different. So example 4 is asking me the same question. It's asking me to find the domain. And I'm having trouble writing, so I'm going to apologize right now. I'm not sure what this will look like, but I'm going to lay my screen down. But it's asking me to find the domain. So I should ask myself, again, what can we substitute into this equation? Is there anything that would give me trouble in this equation? Um, is there anything that I cannot do or substitute into that function? So, I mean, I've been doing math a long time, right? So there's patterns, things that just kind of happen over and over and over again. So what I see when I look at this equation is that is a rational function. And when I say rational, that means that there's a fraction. I see 3 divided by 2x minus 5 is a big fraction. That's all that is. It's a rational function. Well, what do I know about fractions? When do I have trouble? When do I run into trouble? Well, I know that when you're talking about fractions, you cannot divide by 0, right? So what I know is that the denominator, let's write all of this down. We can not divide by 0. Okay, so what does that mean in the context of this problem? Well, that means that your denominator cannot be 0, correct? Well, what is your denominator? Your denominator is that 2x minus 5. So now what I can come back and say is that 2x, oh, I'm about to mess up. Give me just a minute. That 2x minus 5, that cannot be equal to 0 because I can't divide by 0. So now let's set that equal to 0 and let's solve it. We bring that 5 to the other side. That would give me 2x cannot be equal to 5. Divide both sides by 2. And x cannot be equal to 5 halves. Why can't x be equal to 5 halves? We'll try it. Let's see what happens. Let's just test it. If I were to take and substitute 5 halves into this equation, I would get 3 divided by 2 times 5 halves minus 5, which gives me 3 divided by, well, those 2's cancel out. That leaves me with 5 minus 5, which leaves me with 3 divided by 0, and you cannot do that. That's an ugly thing in math. You cannot divide by 0. That's undefined. So what I just figured out is that I can substitute any number into this equation as long as the denominator does not equal 0. The only number that will cause my denominator to be equal to 0 is 5 halves. So how do I write that? How do I say that that x can, or the domain can be any number except 5 halves? Well, I kind of have one answer here. I have that x cannot be equal to 5 halves. I can write that in set notation, and I don't know if I can go to the next screen. Okay, so I can write that in set notation. So I can say that x cannot be equal to that 5 halves. Okay, so that's one way. And another way, in interval notation, I could say that I can include all my numbers from negative infinity all the way up to 5 halves. But I can't include 5 halves, right? So only number I cannot use. I'm using every number up until 5 halves. I'm going to stop at 5 halves because I have something special happening there, right? So I'm stopped there. But union, that means that I'm going to have to finish this thing. Got to add something onto it. I'm going to start right back at 5 halves, but I'm not including 5 halves. I can't actually substitute that into my equation. And then I'm going to go on for infinity. So this is my set notation. This is my interval notation. Then if I wanted to graph this thing, gosh knows, I'm just going to do a lazy mathematician's number line. I'm just going to put 5 halves on here. And what I'm going to do is put like an open circle, and I'm just going to show that everything on this end can be included, everything on that end can be included. I just can't include 5 halves, so I put a big open circle at 5 halves, showing that that cannot be included. Okay, so I hope that helped. And I think I have one more of these. Let me erase that. So this one's a little bit different. So here's the thing about domain and range. Here's what I wanted to go over. The domain and range problems, they can all be different, right? They all look different. You have to think for yourself. You have to try to figure out what might cause some trouble with these problems. So again, we're going to ask ourselves, what can I substitute into this problem, right? I like to say, what's going to give me problems? What's going to cause trouble? Well, I have a radical, right? Think about what cannot happen with radicals. Okay, when we're dealing with the real number system here, I know that I cannot take the square root of a negative number and get a real solution, right? So that's my problem with radicals. Just like, let me go back with rationals, your problem will always be dividing by 0. You cannot divide by 0. So anytime you have a rational function, you should take that denominator, set it equal to 0, and solve it. And that's going to be what cannot be part of the domain. Same thing here with this radical. I cannot take the square root of a negative number. So what I know is that whatever I have up under that radical, and what I have under that radical, oh man, give me just, I'm not as fast as I would like to be with this thing. What I have under that radical is that 4 plus 3x. That needs to be positive or 0, right? Just not negative. So the way I write that is that 4 plus 3x has to be greater than or equal to 0. Cannot be negative. That's how we just say it has to be positive or 0. It just cannot be negative. And then solve it. Okay. So I would bring that 4 across. That would leave me with 3x is greater than or equal to negative 4. Divide both sides by 3. And that leaves me with x is equal to well, no, no, not equal to, slow down one, will you greater than or equal to a negative 4/3. Okay. So what this is telling me is that x, or the domain, can be any number as long as it's greater than or equal to a negative 4/3. So if I wanted to write this in set notation, all I really needed to do was kind of put that line there, put my x there, add my brackets, and that's really set notation. It's super easy. Now if I want to write it in interval notation, then I need to show that I'm going to start at that negative 4/3, and I can include that negative 4/3 because how do I know I can include it? I have that equals to part, right? It's greater than or equal to negative 4/3. So it's actually included there. So I start at negative 4/3, and then I can go on to infinity. Okay. So guys, all of these lessons have what we call quick checks. Okay, at the end of the lesson, I would advise you guys to work through these problems and try them. And if you do not understand them or your homework, shoot me an email and I can make a video just like this if I have time. Now, I'm not going to say for every single question that you send, I make a video. I'm just saying if I have multiple questions from the same people, um, or better yet, let me correct myself on Canvas up under week 2. I know I opened up a discussion board and it's just for questions. So if there's anything you have questions about, um, post it there. Problems, anything. And if I have time, I can actually upload videos explaining some stuff. Okay. So please ask questions. That'll make the class more engaging, and everybody can benefit from it. Um, and I think let's discard. Um, I actually had for lesson 4, R.4. I wanted to kind of look over that with you guys. And I know this is long, but you can always pause this video, stop it, come back later. This is just to help you guys out. So I'm gonna look at my PowerPoint slide right here really quickly. I'm not gonna go through all of this stuff. Um, okay. It says find the equation of a line with a slope of 3 and containing the point of -1, -5. So what they went over just before that example, and we'll go back to it, is they went over the slope-intercept form of an equation. So y equals mx plus b. So at this point, that's all they've given you. So they've given us, let me lay this down, I can write. They've given us that y equals mx plus b. And they're asking me to write an equation of a line containing this slope, and it's going through that point there. So what do I know from that? I know that my slope, and m stands for your slope is 3. And I know that I have an x coordinate of -1 from this ordered pair, and I have a y coordinate of -5. Well, guys, I like math because you just take what you know and you use what you know, substitute it in. You have to think logically, right? So I know a few things from this word problem. I take what I know and I substitute it into the equation that they gave me. I have a y value. My y value was at -5. I have a slope, which is at 3, right? I have an x value, which is at -1. But what I do not have is at b. I don't have my y-intercept. To write an equation in slope-intercept form, the two things that you need is, one, you need your slope, and then you need your y-intercept. So they gave me the slope in the word problem, but they did not give me the y-intercept. So what I was saying a few seconds ago is you take what you know and you substitute it into the equation. Well, if I take everything that I have and that I know from this problem, and I substitute it into the equation, the only unknown that is left in this problem is the b. And that's helpful for me because now I can actually solve for that b. I can solve for my y-intercept. So if I solve this, this would actually give me -5 is equal to -3 plus b. Add 3 to both sides. And that leaves me with a -2 is equal to b. And that's nice because I told you guys that the two things that you needed was a slope and a y-intercept. And I had the slope, and now I have my check my y-intercept. So that's the only two things you need. You take your slope. My slope was 3. You substitute that into the equation. You leave the x and the y. And then my b was -2. So I'm going to say -2. You substitute that into the equation and you are done. And let's just say you're not sure if you got it correct, right? All you need to do is take those points, -1 and -5, you substitute that into this equation. And if it works, if it gives you a true statement, then you know what you have is correct. If it gives you a false statement, then you know that what you have is incorrect. So what am I talking about, true and false? I said that in my calculus class last week, and some gave me a look like they were kind of confused. Let's make sure you guys understand. So if I take that -5 is my y value, right? So substitute that in the place of your y. And then in the place of your x, substitute what you have for your x value there, that ordered pair. And I want to know, does that give me a true statement? In other words, on this side, I had a -5. Do I get -5 on the right-hand side? Well, 3 times -1 is -3, and -3 minus 2 gives me -5. So yes, it does work. It gives me a true statement. So I have my equation in slope-intercept form. That equation gives me a line that has a slope of 3 containing the point -1, -5.